Good day everyone. Today we will discuss sequences and series. But before that, let us define first what is the difference between the two. When we say series, it represents the sum of the terms of a sequence, while a sequence is a function whose domain is the set of positive integers or the set of 1, 2, 3 up to n. In other words, a sequence is a list of numbers separated by commas, while a series is a sum of numbers separated by positive or negative sign. The sequence with the nth term is usually denoted by a sub n, and the associated series is given by S is equal to a sub 1 plus a sub 2 plus a sub 3 up to a sub n. Let us have an example. Let's say here in associated series we have 5 terms. And these terms will be S is equal to a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. This is now the associated series of the 5 terms. Next, let us identify the following items as sequence or series based from the definition a while back. Number 1, is it a sequence or a series? 1, 1/2, 1/3, 1/4 up to 1/8. Very good. Number 1, this is an example of a sequence because it is separated by commas. How about number 2? 9 plus 12 plus 15 plus 18 plus 21 plus ... up to 45. Is it a sequence or a series? Very good. This is an example of series. It is separated by positive sign. How about the third one? Negative 15, negative 9, negative 3, positive 3. This is an example of series. Very good. Separated by negative or positive sign. How about number 4? Negative 15, negative 9, negative 3, positive 3, up to positive 15. This is an example of, very good, sequence. Because it is separated by commas. And the last but not the least, number 5, we have 1, 1 over 10, 1 over 100, 1 over 1000, up to 1 over 10 million. The answer is very good, sequence. Good job, class. So you know already the basics. You know how to define, differentiate series into sequences. Now let us proceed with the next problem. Let us determine the first 5 terms of each defined sequence and give their associated series. For number 1, as you can see, a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5 are the first 5 terms that we need to determine. So first, let us write all those terms. We have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Because it is our task to determine the first 5 terms. What do you mean by the subscript here. A sub 1 means this will be the numbers that represents the values of our n. I repeat, 1, 2, 3, 4, and 5 will be substituted to the variable n. So let us write. Is equal to, copy the given 2 minus, your n will be 1. Next, 2 minus 2, 2 minus 3, 2 minus 4, and 2 minus 5. We have A1, A2, A3, A4, and 5 because we are looking for the first 5 terms. And A1 means the numbers here represents the values of n. So we will substitute 1, 2, 3, 4, 5 here in our n. Let us simplify. 2 minus 1 is 1. 2 minus 2 is 0. 2 minus 3 is negative 1. 2 minus 4 is negative 2. And 2 minus 5 is negative 3. Therefore, for the associated series, we will write it as S is equal to A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 and plus A sub 5. We will just input the values of our answer for A1 up to A5. And for our A1, we have the value of 1. Plus A2 is 0. Plus your A3 is negative 1. Plus your A4 is negative 2. And then plus your A5 is negative 3. Let us simplify. Our associated series will be 1 plus 0 minus 1 minus 2 and minus 3. That is how to solve the first 5 terms and of course how to write the associated series given the following terms. Next, number 2. How about A sub n is equal to 1 plus 2n plus 3n squared. We still need to determine the first 5 terms of each defined sequence and give their associated series. Again, the subscripts of A will be substituted to n. We have our first subscript of 1, A sub 2, A sub 3, A sub 4, and A sub 5. All the subscripts will be substituted to our n here. So let us write 1 plus 2 times 1 plus 3 times 1 squared. Can you follow? Next, for A sub 2, 1 plus 2 times 2 plus 3 times 2 squared. Next, 1 plus 2 times 3 plus 3 times 3 squared. 1 plus 2 times 4 plus 3 times 4 squared. And last, 1 plus 2 times 5 plus 3 times 5 squared. We already substituted all the values of our subscript to our n. Next step, let us simplify. 1 plus 2 times 1 is 2 plus 1 squared is 1 times 3 is 3. Next, copy 1 plus 2 times 2 is 4 plus 2 squared is 4 times 3, 12. Next, 1 plus 2 times 3 is 6 plus 3 squared is 9 times 3, 27. Next, 1 plus 2 times 4 is 8 plus 4 squared is 16 times 3, we have 48. Then last, 1 plus 2 times 5 is 10 plus 5 squared is 25 times 3 is 75. Now let us compute further values of our a sub 1 up to a sub 5. 1 plus 2 plus 3 is 6. 1 plus 4 plus 12, 17. 1 plus 6 plus 27, 34. 1 plus 8 plus 48, that is 57. And 1 plus 10 plus 75 is 86. Since we already solved for the terms of A1, for the values of A1 to A5, let us now write the associated series. So we have this statement, S is equal to A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 plus A sub 5. Next, we will substitute for the values of A1, A2, A3, A4, and A5. Our A sub 1 is 6 plus A sub 2, 17 plus A sub 3 is 34 plus A sub 4 is 57 plus A sub 5 is 86. This will now be our answer for number 2. Next number. Let's proceed with the third example. We have here A sub n is equal to negative 1 raised to n. Remember, class, that if the base is negative and the exponent is odd, the answer is negative. And if the base is negative, while the exponent is even, the answer will be positive. Let me write. For example, we have negative base. The negative base with an odd exponent, the answer will be negative. And if your base is negative, still negative, but the exponent is even, the answer will be positive. Okay, so let us write the first 5 terms of number 3. We have here A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. We will substitute the subscripts here 1, 2, 3, 4, 5 to our n. So we have negative 1 raised to 1, negative 1 raised to 2, negative 1 raised to 3, negative 1 raised to 4, and negative 1 raised to 5. Let us simplify. Just like what I told you, if the base is negative and the exponent is odd, the answer will be negative. So we have here negative 1. But if the base is negative and you have the exponent of even, the answer will be positive. So we have positive 1. Next, negative 1 cubed. It is odd, meaning to say the sign is negative. Next, the exponent is even, positive. The fifth one, we have negative 1 raised to 5, we have negative 1. So those are the values of our A sub 1 up to A sub 5. Now let us write the associated series. S is equal to A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 plus A sub 5. S is equal to, our A sub 1 is negative 1, A sub 2 is positive 1, so plus 1. Then a sub 3 is negative 1, a sub 4 is positive 1, and a sub 5 is negative 1. This is now our answers for number 3. Okay, let's proceed with our last but not the least example. For number 4, we are given the set of 1 plus 2 plus 3 plus ... up to plus n. We need to get the first 5 terms, and it deals up to n. So if we have a sub 1, this will be automatically 1. A sub 2 is equal to 1 plus 2 because it deals with the number of terms. Next, a sub 3, we have 1 plus 2 plus 3. A sub 4 is equal to 1 plus 2 plus 3 plus 4. And a sub 5 is equal to 1 plus 2 plus 3 plus 4 plus 5. So let us simplify. A sub 1 is 1. A sub 2, 1 plus 2 is 3. A sub 3, 1 plus 2 plus 3 is 6. A sub 4, 1 plus 2 plus 3 plus 4 is 10. And for a sub 5, 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. Now let us write the associated series. S is equal to a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. Substitute the terms. You have 1 plus 3 plus 6 plus 10 and plus 15. So that's it for series and sequences. Thank you and God bless.